Okay, let's continue with the hypothesis testing. Okay, in hypothesis testing, the nature of the hypothesis testing same with the hypothesis testing in chapter 5. But in here, we used to test whether the correlation the hypothesis testing is used in this chapter is to measure whether there is correlation or not. Okay, let's see. The first thing is when H null. H null meaning that there is no correlation between the X and Y variable in the population. Okay, H alternative, H1, meaning that there is a significant correlation between the variable in the population. Okay, so here you can see this one is we use equal and this one is not equal. Okay, what is meaning of not equal? So not equal meaning that this is a two-tail test. Alright? Okay, so in hypothesis testing, we have t-test for the correlation coefficient. So the formula for the t-test is t for the t-test equal to R. R is a relationship. Square root of n minus 2 divided by 1 minus R power of 2. So n is a degree, n is the number of variable. So the degree of freedom is equal to n minus 2. So let's say if the example want to search for the degree of freedom, so we just take the value of n minus with 2, right? Okay, let's see the example. Okay, example 10.7, car rental companies. So this example, we use the same example. Sorry, where is it? The car company. Okay, this example. Okay, remember we have 6 company. So this 6 company is n, value of n. And car for value of X, revenue for the value of Y. So go back to this example. Okay. And then use alpha equal to 0.05. And R. What is R? R is a relationship. 0.982. So how to find the value of R? How to find the value of R? We already searched for the value of R before. Here. By using what? By using the correlation coefficient formula. Okay? Alright. Okay. So, the first step, we have 5 steps as usual. The first step is to state the hypothesis. Second step is to find the critical value. The third step is compute the test value. Step 4 is make the decisions. And the last step is to summarize the results. Okay, first one, state the hypothesis. Okay, the second one is find the critical value. So alpha is equal to 0.05. Degree of freedom is 4. Okay, okay, and then search in table F. So where is table F? Table F, where is it? Table F. Okay, table F. (0.05). So two-tail is here, 0.05 is here, and degree of freedom is 4. So this one, 2.776. So 2.776 because it is two tail. So plus 2.776 and minus 2.776. Okay. And then compute the test value. So test value T is equal to R. So R 0.982 and is 4. Okay. And we will get the answer for T is 10.4. Okay. So make these decisions. So draw your binomial distributions. You can see that this is your two tail the value coming from the table F, and this one is the test value 10.4. Okay, so from here that you can see that 10.4 is inside the critical region. Okay, so once it is inside the critical regions, so meaning that we must reject the null hypothesis. Okay, and then for the last step is there is significant relationship between the number of cars a rental agency owns and its annual income. So the main important things in step 5 is you must show that there is a significant relationship. Okay, significant relationship. All right. Okay, so here I already stated this is a two-tail test. So you must see the table F. So make sure you see in table F for the two-tail. The degree of freedom is 4 and alpha is equal to 0.05. And also, I note this one as fall in critical region. Okay? And highlight this one, significant relationship. Alright. Okay. Let's continue. Okay, this one. Okay, the possible relationship between variable. Okay, there are five possibilities that can exist between the variables. The first one is a direct cause and effect relationship between the variable. Okay, the second one is reverse. This one is direct, reverse, cause and effect. And then the third one is coming from the third variable that caused by the third variable. And four, may be a complexity interrelationship among variable. And the fifth one is coincident. All right. Let's see the example. What is meaning of reverse cause effect? Okay. For example, water causes plants to grow. Okay. Which one is Y? Which one is X? Yeah. The second one is poison causes death. Heat causes ice to melt. Okay, this one is reverse cause effect. Okay. Sorry, this is not reverse cause effect. This one is a direct cause effect. Yeah. Let's take note. This one is direct. Okay, direct cause effect. Okay, so this one is an example for the reverse cause effect. Example, suppose a researcher believes excessive coffee consumption causes nervousness. Okay, but the researcher fails to consider that the reverse situation may occur. So meaning that the researcher said that coffee nervous, but is it true that nervous is coming from the coffee? Right? And then the relationship between variable may be caused by third variable. Okay, the first variable is a statistician correlated the number of death. Okay, first one is death. Okay, coming from the due to drowning and the number of cans of soft drink. Okay, death, number of cans, second variable. The third variable is the summer. Okay, so this is a relationship between caused by third variable. So third variable is coming from the summer. Alright. And then there may be a complexity interrelationship. So maybe lots of coming from lots of variable. So here we have IQ, hours of study, influence of parents, motivation, age, and instructors. Okay, and the last ones may be from the coincidence. Okay, so a researcher may be able to find a significant relationship between the increase in the number of people who are exercising and the increase in the number of people who are committing crimes. But common sense dictates that any relationship between these two variables may be due to coincidence. All right.